sharing screen. Can you see my screen? Not encapsulation, all that. We'll come back to this again. So yeah, this is where we are talking yesterday. We just done with what is it, friends? With inheritance, single inheritance. We had discussed about single inheritance in yesterday's class probably, and we had discussed what is it about the relationship between parent and child, and what exactly we should do when we have a parent class and child class. To which class should we create object, and how to access that methods of parent from child. All that we have discussed in yesterday's session. Okay, so now let's continue and let's complete the other things. Okay, and we'll go more and more on this stuff. Okay, right. So the next scenario is this is discussed and we completed this. What is the next topic? Next topic is this is single inheritance itself. Okay, multi-level inheritance. And one important point. So always in inheritance, properties are inherited from parent to child class. And reverse is not possible. We cannot inherit properties of child to parent. This is not possible. So this is a very important point. So if anyone is just new to inheritance, we have to emphasize on this point, right? This is very important, friends. Now after that, let's jump to the multi-level inheritance. Multi-level means simple, friends, same thing, little extinction. If it is single, one parent and one child class, one subclass derived from one parent, that is single inheritance. Multi-level inheritance is nothing, deriving a subclass from a superclass, okay, and then in turn deriving another subclass from derived class, and so on. Again, one more subclass from that, and one more subclass from that, and it goes on. So if you look at this small picture, you get that quick idea. B is inherited from A, C is inherited from B, and D is inherited from C. Likewise, it keeps going on. Such type of inheritance is multi-level inheritance. So, and inheritance means, what is that inheritance? Whatever properties that is there in the superclass, all that properties are inherited to subclass except private properties. Okay, and that is what we call just a minute. Sorry, friends, there was a slight noise. Okay, so just try to fix that. Yeah, this is multi-level inheritance, friends. You got it right. So in any kind of inheritance, what is there in a class? We just have that super class has variables or methods. All that is there. Those members can be inherited to subclass except private properties. We'll talk about all that. First, we'll finish off all the concepts. Then I'll come back again. We'll talk about different other things. And always you can see here, a bottom level class, that is subclass, has access to all its top level classes. Got it right, friends? In multi-level inheritance, especially, a subclass can have access to all its top level classes. Suppose if it is D, D can access properties of C, B, and A as well. So that is the idea. If it is C, C can access properties of A and B, something like that. So that is what the point is. A bottom level class or a subclass has access to all its top level classes or super classes. Okay, this is the simple example. Let us apply this. Okay, implement it and see how this works in inheritance. Okay, let us just create a new program. Right click and create new Python file. And this is a multi-level. This is not multiple, multi-level inheritance. Okay. So now you can copy that the single inheritance program as is if you want. Okay, otherwise you can type it also, no problem. Class A, just create a class. And if you want, you can create one constructor for initializing just some values. So just define def underscore underscore init. Okay, I'm just defining two variables. I'm not going too much into this. So self dot sum x equal to 100, self dot y equal to 200. Okay. If you want, you can use a method to print this x and y, else this is enough. Okay. So I'm just adding for printing purpose, def get a. Get a means get all details from class A. That is the meaning. So now print, just print it. Okay. You can use okay, for testing only, right? If you want, you can add the description, friends. Okay, that the value of x, the value of y is, by now you know all that, right? Self dot y. So this is a simple class with two methods. One initialization method, that a constructor. One method just to display values from object. Okay, that is the idea. Next one, class B. Let's take class B. Let us inherit it from A. Then I do one thing. I just do some addition here. So what is that I do in this self dot result? Okay, equal to self dot x. Okay, plus self dot y. I'm just doing addition in this B class. Okay. So, but what I am doing here while doing addition in B class, I am using properties of A in B class. So this is fine. That itself proves this is possible because of inheritance. We are able to use properties of A class directly in B class, and that is possible due to inheritance. This is okay. Next, after that, take another class C. Okay, class C, simple, inherit B to C. Okay, what is that we should do? Inherit B class to C class. This establishes multi-level inheritance. This is how we have to create relationships. Got it, right? So now what is that we should do? Take another method. Okay, maybe you can call this as product. Okay, just change this to some product or something, anything that should be fine, friends. Then what is that here? Result to equal to self dot x into self dot y into self dot what is that I want result. So whatever result I have in B class, I am doing product of that as well. Something x into y into the result of B class from add method. So completely this clearly establishes a strong this thing for multi-level inheritance. Strong scenario for multi-level inheritance. Why? If you see C class, C is trying to use properties of B as well as A. Right? Similarly, B is trying to use properties of A, which is its superclass. Okay, these are the properties X and Y. That establishes the multi-level inheritance. Okay, now what do we do? Recommended. We don't need to create object for B class or A class. If we just create for C, that would be enough for us. So what do we do? Yeah. So now C equal to C. Okay. Then what shall I do now? If everything at class level, at C class, at C level should work, then we must, what is that we should do? We must follow proper process. First, we should call this method from A because C is using X and Y from A class, and this method from B because C is using result from B. So if you want to have all this in C, what is important here? Calling these dependent methods or variables on C object is very important. On C object is important. Got it right, friends? So what should we do now? First on C, call which one we have to call. We don't need to call anything, of course. See this constructor, right? Do we need to call it? No need. Why? A constructor is automatically called whenever an object is created. Then you ask me a question. That is for that particular class, right? Yeah, this is inheritance, right? Even if you create object for subclass, that subclass implicitly is going to call its superclass constructor. There will be a chaining of constructors implicitly. Implicitly, you don't see that. This subclass will call its a superclass constructor B, and this B will call its a superclass constructor A, and this constructor chaining happens from the very bottom level class to the top level class if they are default constructors. Got it right? Suppose if I try to run now, so call this method. This is add is a concrete method, right? So you have to call that. If it is constructor, we don't need to call it. If it is a concrete method, right? Then what is that we should do? We have to call them explicitly. So what shall I do now? C dot first thing. If you want to see that value of X and Y, just call that get a C dot add, and finally C dot prod. Okay. So that's it. So this is how we should make a call of methods from superclass to subclass, from top level classes to bottom level classes. And we should make sure we are following the dependencies clearly. Got it right, friends? This is very important. Now, let's run this. If you want, you can debug also, but first run this. The expectation is when you create C class object, it will automatically call this constructor. Then let me just show you the execution flow once, how this will be. If you want to know more deep into this object creation, how this C class object will be, this is your C class object. Let me just show you. This is very interesting thing, friends. Okay, I really loved this approach. This is C object. Okay, definitely object means, right, friends, it has some address. Okay, and this address is stored into some reference that is nothing but C itself, which is small c, not capital. And this small c holds the address of its C class object. Now C is pointing to which one here? C is nothing but pointing to C class object. Till this it is fine. Now let us get into the secret of this object. Again in the C class object you have one more object. What is it? It's immediate class object, right? Implicitly, not externally. Of course, as a whole, C is just one object. So does C have any parameters? Exclusively C object has what? This one resulted to, right? This will be part of C class object. Of course, everything will be inside C only, but see the layering approach, right? If you see this, this is C. This variable exists inside C. Now, what is that? C, P class object. When internally again you have a P object, and this variable exists inside P. Okay. See, this is how it would be interesting, right? And again, inside B, there will be one more object, which is nothing but A class object, right? And what is there inside A object? We have X and Y. And that X and Y will be inside this A object, X and Y, which is nothing but Y is 200, X is 100. Similarly, this one self dot result is 300. Okay, this is set to 300. This 100 into 200 into it comes 100 into. I'm just giving you 300 into 200 into 300. You can just calculate it. Okay, that way that value will be inside self dot result 2. Got it right, friends? So this is how the object is organized internally. Interesting, right? So, so this is something really useful thing. But as a whole, this C is one object. But C internally has A class object and B class object as implicit objects. Now, what is the point here? If you don't call these methods, what is that? If you are not calling this constructor, okay, that is one thing. It anyhow it calls automatically, but giving you an idea, right? Setting that background for you. If you don't call constructor or if you don't call this B method, okay, that is add method, then this XY and this 300 don't exist. Without existing these two, if you want to do this product, it is not possible at all. So that is why you have to set that dependencies properly. That is very important in programming. Okay, so this is the idea, friends. So you got it right. Interesting. And these methods, whatever methods you are seeing, what is that? All these methods. Let me just again show you this get a. Okay, or next one is what? One more method is add method. Okay, let me just show you. So get a will be working on this, okay, but on coming from A class and add method. And I'm just writing outside like this and prod method. And of course, one more is init method. All this. All these are applied on this object. All these methods. I'm just writing like this. First init is called, which initializes A class object internally. Then when you call get a displays values from this A object, which is internally to C. These are all inside C. Don't think they are different objects. For your understanding, I'm showing you all this. Again, when you call A add will set this value to B object. And when you call product set this value to C object. And that is how it works. Of course, I am missing printing these results. Just let me add a print here, quick print. So what is that? Self dot result. And here also, what is it? Self dot result 2. Okay. And finally, what is it? You can run this program and you can see the output, proper output here, 100, 200, 300, and finally it is something like 6 lakhs or something here. Got it right, friends? So I think probably we have 6 zeros. Okay, 6 zeros are, yeah, means 60 lakhs probably. So that is the output we have here. Okay. So that's the idea, friends. That's the idea about what multi-level inheritance, how object is internally created and how it looks like. What is this creation thing in object? When we create objects of subclass, how it looks like, right? And all this stuff. This is clear, right? That is the idea, friends. So I'm just sharing this program with you. Code wise, this is nothing. We just do a very simple and basic program. But this analysis is something really wonderful thing. Okay, just try to get this. This would be useful. Okay. So now let me just share this with you. Sharing this. Mhm. Okay, and next after this is so this is idea about multi-level inheritance. Finally, you got it right. what is the point here? A subclass is able to, here the bottom level class is able to access all its top level classes and members of all its top level classes. And that is what multi-level is. Even if you want, you can also create object for B class. That is fine. Got it right, friends? And call method from B and A class. Don't try to call again something from C. That is the idea, friends. Okay. So next one after that, let's get into the topic of hierarchical inheritance. Hierarchical is simple. This is a one-to-many relationship. So this single inheritance is one-to-one relationship, technically speaking, if you want to talk in terms of relations. Single inheritance is one-to-one relationship. Hierarchical is one-to-many. Multiple is many-to-one. Multi-level is should be something like what shall we say? Many-to-many. It's not many-to-many, but one-to-many, something like that. Even that hierarchical should come. So this relation is a different one. But if you correlate with our mathematical programming, so these three has a proper correlation. Single, one-to-one, hierarchical, one-to-many, multiple, one, many-to-one. Many-to-many, you can take it as hybrid. That's how you can create all these relationships, friends. Okay. So now let's get into the hierarchical. Hierarchical is a very simple scenario. What is that? One-to-many means what? If you derive two or more subclasses from one superclass, or two or more child classes from one parent. Got it right, friends? So that is hierarchical inheritance, right? Deriving more than one child class from a parent is hierarchical. And here, like in multi-level, what is the thing in multi-level is, so there will be relationship between one subclass to another subclass. At least D has, if you talk about D, right? D derive properties of all its parent classes. C derive properties of all its parents. B derive properties of its parent. Means what? One child has some relation with the another child. Either that child acts as a parent or a subsequent child. Some relation between them exists. But if it is hierarchical, all that relationship for childs or subclasses is with the parent directly. One child class don't have any direct relation with another child. You got it right. So that is what important difference between that multi-level and hierarchical. Maybe you can ask me, if you don't have direct relation, can we have indirect relation? You might ask this question. Definitely. So whatever we are implementing here is this inheritance is a relationship. What is that? This is a relationship. So if it is easy, we strictly follow inheritance approach here. Suppose if it is indirect approach, we apply has a relation. What is it? That has a, we can say that has a relationship. These are really useful things. I'll talk about this once we complete all these topics. Okay, I'll also show you what is that has, how to apply it, right? And if possible, I'll bring in more useful use cases for you, one or two, not too many. So that is has it. But finally, what is the point with hierarchical? Here, we derive two or one or more subclasses from a superclass. Okay, one means it will be always single inheritance. More than one subclass from a superclass is hierarchical. And one important point is one subclass don't have direct relation with another subclass. Here the relation is always with super, like employee and employer, right? All employees are connected to employers, but one employee don't have direct relation with another. So that is the kind of relationship we have here. And another important point is here one subclass don't have access to another subclass directly. And syntax is simple, right? You have a parent, you have two childs. Both childs inherits the parent. just in the brackets, we have to pass that parent here. If it is this one, what is that multi-level, that changes. What is that? B inherits A, C inherits B. There is a slight change. So that is the idea. Let's apply a small program and close this example. Okay, I mean hierarchical inheritance. Let's take one more example. New, sorry, right click new, Python file, hierarchical inheritance. Now you just take class A simply and just define a few parameters in that. If you want, you can take that init method again. And if you want, if you can also make it parameterized, it's up to you. For testing purpose, I am just using hard coded direct assigned values. Okay. So self dot x equal to 100, self dot y equal to 200. Okay. Maybe again, if you want, if you want to print that, you can say that get a, and then you can just print it as self dot x, again self dot y. Now let us try to inherit two subclasses, both subclasses inheriting a class, that is hierarchical. One parent, many children, that's all. Okay, so what do you do? Take class B, inherit it from A, colon. Now, same as usual, you can follow the same previous kind of example. Only difference is here we don't have relationship between child classes. That is what hierarchical is, right? So add, we can directly say self dot sum result equal to self dot x plus what is it, self dot y. This is over. Take another example, class C. Just change it to another class C, and we do product in C class. Or you can create anything of your choice. For testing, we can add C. So, sorry, we can add product. So add prod, but this time don't try to use anything from B class because these two childs are not connected or related. Both B is different and C is different. Okay, so what B and C should do, should inherit properties from A. That's all. Okay, now what do you do? Self dot x into self dot y. That is enough. And you can put, if you want, you can use the same instance variable in both methods, like method in A, B class and method in C. Else you can change it. Result 1, result 2. And finally, what is that we should do here in hierarchical inheritance? We should create a separate object for each subclass, right? For whichever the subclass you want to test. For that subclass, we should create object separately. Like if it is multi-level, if you just create one object at bottom level, that will access properties of all its top level classes. That in that way we can do testing. But hierarchical, we have to create object for each subclass if you want to test at subclass level. So what do we do? Let's do one thing. Let's test both subclasses B, B. So this will automatically call it superclass constructor. So B object is initialized. So what do you do right now? If you want to see what is there in A class, call that get A. And then finally, if you want to call that add method, call B. Don't call prod here because prod is in C class. We should call that on C object. Now again, create one more object for C class and then say B dot, again call that get method on C object, not B, C here, on C object. Already we are calling on B. And finally, C dot what? Yeah, sorry friends. C dot prod. Still, I am not recovered from this cold and cough. Okay, but it's okay. So this is the idea. So finally, this is how we have to implement hierarchical inheritance. So right click, run this, see here, B object. Okay, no problem. We can fix it, not a big deal. What is happening? We are inheriting, okay, B object has no attribute. We are inheriting this, right? Yeah, that should call that. Okay, one more thing. Yeah, this is defined as a regular method. See there, I didn't create init properly. So this becomes a concrete method, not a constructor. And that is why B is not able to invoke or access this init method. This declaration, I had a typo issue. I didn't declare it properly. So that is why it didn't work. Got it right, friends? Only that constructor has that kind of approach. Not all methods are called directly. Except constructor, every method should be called explicitly. Got it right? So I fixed the typo. Let me run this now. This time it should work. Okay, right click, run this. See, definitely it's working. See here. Right. So we didn't get the result because we should print it. Let me print it. Okay. It's self dot result one result two. Okay. Let's run this now. See, perfect, right? So here you can see 100 plus 200 is 300. Here 100 into 200 is some 20,000. So that is the idea, friends. Got it right? So finally, this is what hierarchical inheritance is about, friends. So I hope everything is clear for all of you. Understood? So we made every point clear, and we had also discussed difference between multi-level and hierarchical. And this should be very clear for all of you, friends. Okay. Next scenario is what? Multiple inheritance. So what is multiple inheritance now? Now we had discussed all this, right? What is that, friends? About single, multi-level, hierarchical. Multiple means many to one. Many in sense, many parents, one child. What is it here? Deriving a subclass from two or more parent classes or super classes or base classes. So that is multi-level inheritance. Okay. Multiple parents, one child. This is multi-level inheritance. Got it right? So how do you implement this? Simple. First create multiple parents and then try to inherit all these parents to one subclass. Got it right. How do you do that? This is the syntax. Parent, create parent one, parent two, child. In brackets, just pass all that parents list here. You can also create, inherit two classes, three classes, four classes, how many ever you want. This is American system. Okay, just for fun, I am saying. Right? So, one child can have multiple parents. I hope this is clear. So, what is the syntax we should follow? That's this one. If it is multi-level or hierarchical, we just pass that specific parent, whatever we should inherit. But for multi-level, multiple, we pass multiple parents in this bracket. That is the only difference. So let us apply this. Now we know syntax. We know what is multi-level. This is many to one in a way. So let's apply this example. So what do you do? Just create, right click, new, and then say multiple inheritance. Okay. So just create two subclasses. Class A, just put some again a init method, and then just define two variables, self dot some a equal to some 100, some 10, self dot some b equal to some 20. So this is one superclass. Okay, let's create one more superclass. If you want, you can print that values as well, as we are already doing, right? So just say get a and just print what is that. Okay, if you want, you can just say the value of a is okay, and then let's put this flower bracket here, just pass self dot a, and here just use that f here. That should set the this thing for there. Now again, the value of a is the value of b is okay, is self dot b. Next, after that, create one more class b. Okay, class b is simple thing. Again, use another init method, and here just set some x equal to 10 and y equal to 20, and then get b, and then print that x, and print that y. So this is, you can see now, and just change that the value of x is okay, the value of y is all this. So we have two parents. Now we are ready with the inheritance now. Let's take the child. So inheritance means deriving a subclass from two or more parent classes, right? We created two parents. Let's create a subclass now, class C, and here put A comma B. Let's both inherit this. Let's C inherit both these parents. So what happens now in multi-level multiple inheritance? The subclass C can access properties of A and B, both from A class and B class. Of course, these two parents are not connected. They are not related. A is different, B is different. Whatever is there in these two classes, those two can be inherited to C class. Now using these variables of A class and properties of B class, let us do a small calculation, maybe addition or multiplication or anything you think it should be fine. Let's do add here. Okay, you can just say some self dot result equal to, just for testing we are doing that, so just to show you that this is how multiple inheritance work. Self dot a plus self dot b plus self dot x plus self dot y. You got it right. If you want, you can print it here. That's all. So do a small printing. What is that printing? Print this result of C class. The value of result is okay, self dot result. Now finally, what is it? We are done with this. This is multiple inheritance. Deriving a subclass from two or more parent classes. Minimum two are important. So this sets multiple inheritance. Got it right. So right click, run this. Right. So we don't see any output. Very nice. Why am I printing result here? We are missing the very important core thing of programming. What is that? Creating object. Okay. And calling methods. We didn't do this right. Of course, on C, you don't need to call constructors, probably both this time this is a challenging thing. Let us see if both these constructors are automatically called. So let us see that how it works. Now after that, next one, C dot get A and C dot get B and C dot, what is that, add. Let us see this. This is a quite intriguing scenario. Why? Because So far, a subclass is able to call when you create object for subclass, that subclass object is able to invoke superclass constructor. But this time, this subclass should be able to call two constructors, one from A and one from B. This is something a bit typical situation. So let us try to run this and see what happens here, right? So this is interesting point here. Let us see this. So yeah, I am expecting some kind of this. What is that? C object has no attribute X. X means that is something from B class. What is happening is C is able to happily call which one? A class constructor, but not B. See, let me put a debugger. This is interesting, friends. Okay, so debug. This guy, what is it doing? C class. So let's see this now. So you can see that the infra that is created here, all that variables, A is loaded, B is loaded, C is loaded, all three classes are loaded. Next what? Step into, if you do this, it is going into A, but not into B. Why? Any idea? Why is it going only to into A, but not into B? Because in the order of inheritance, which one you are inheriting first? A class. So by default, the priority is given to A. That's why the constructor of A is called, but not the constructor of B here. You got it right, friends. So then then if it is if we are not able to call constructor of B, then we miss out on this initialization from B, that X and Y. And if this is not happening, then we fail with this add functionality. So somehow, if C is not directly calling B, then we should create something to call constructor of B class. How do you do that? Right? Is there any way to do that? Yes, definitely. We can explicitly call a superclass method by using a method like super, I believe. So what do? You can say super dot init from subclass method. When you are calling add method, you call it superclass constructor because you got that point, right? And this constructor should be called on what? Should be called on C class. Got it right, friends. It should be called on C class object. So better you call this super method inside this add. Let us see this if this is going to work. Okay. So now what do you do? So let's try to run this now. We created C object get A get B, and we are get B anyhow don't work immediately because if get B should work before that this init should be called. So point is then we should do one thing then. Let us inherit like this. I'll try to do this. Inherit B comma A. Okay, because B is called first. From B, let us try to call it's a superclass constructor, which is nothing but A. That is much more best approach of chaining constructors. C might call B and B call its superclass constructor. This is much more recommended scenario. Let's try to run this now and see how this is going to work for us. Okay. So run this now. Super dot disk. Okay, let me put up this is there. I'm very sure of that. Run it now. Yeah, see there. Perfect, right? That parenthesis I missed here, friends. This is interesting thing, right? So what is that? I'll again give you a very detailed explanation here. If anybody has any confusion on this point, line 13, I will explain. I will explain that. Don't confuse. Okay? But this is the idea. Finally, am I able to achieve what I want to achieve? Right? So let me debug this first thing. So you get an idea. What is this super dot? This super method is a method which is used to invoke members of its superclass. It might be a constructor, it might be a method, concrete method, it might be variables, whatever it is. From subclass scope, if you want to access superclass members, then what is that you should do, friends? You have to use this super method. A super method is a method which is used to invoke superclass members, whatever it is. That member can be a constructor or a method or a variable, whatever it is. From subclass, either from subclass constructor, subclass method, whatever it is. We see more of this in tomorrow's session. Okay. And also I'm just making small change to these variables because both are 10 and 20 means we 100% we don't see the exact difference. So let's put like this. That makes more sense to us. Okay. Also, let us debug this. This gives you a detailed idea about the execution flow. Right click and debug this. Interesting, right? This is how OOP is. So this is something really, if you get more deep and deep into this OOP, object-oriented programming, it's more interesting, friends, and it's beautiful as well. Okay, let's get into the point. Right? So we are getting into discussion. See how many classes are loaded. All three classes are loaded. Whenever we start executing program, automatically that class loader, whatever that is there, you can see this loader that loads all these classes into memory. Memory is nothing but RAM. And Python is showing you all this without any difficulty. If you want, you can make a driver as well. I do want, you can put some define main. Okay, this is how we create some programs in our project. Okay, and then so best thing is you can add something like if underscore underscore name underscore equal to, you can just say what is that you should do? Put main, and from that, if you want to start initializing your program, then you can do like this. It's more like mimicking other traditional languages like Java or C Sharp. Now, let us start putting a debugger here. This makes more sense for us. Okay. Now, what is that you do? Now, test this program. Now, we are at main. Let's get into the step into main. Now we are at main, and you can see calling C. Now, what is that we want? Let us again say step into, because this when C class object is created, it try to call its superclass constructor. What is that? That B class constructor by default. Because in the order of inheritance, which one we are inheriting? B and A. Then it invokes B class constructor. If you put A and B here, it invokes A class constructor. So I just made a flip here because calling A class constructor from B class constructor is a best approach. So that is why we did a flip here, friends. Okay, finally, what do you do? Step into. Then we came to B class constructor. And you can see that it is passing what here. If you observe carefully, to this B class constructor, it is passing C class object. See, this constructor is working to initialize C object. You can see here, friends. Now again, it doesn't stop here. Now when you call B class constructor, now there is again a nested call, a constructor call again. So when you have this continuous chain of calls, all that calling happens first. Now what happens? Again, this calls its superclass constructor, which is A. Now again say step into. Now it goes to its topmost class, which is A. And still you can see something here. What is that? Main.c. Still the object is C class object. It's not B, it's not A, but still the objects belong to whom? It is just the C. So even this constructor is initializing C object. That means this is initializing C. All this self, if you print self and C in this case, they hold this C object. Got it right. Understand this, friends. Okay. Now what happens? You can say step over. Okay, step over. Then execution of this constructor is done, and this initializes what is it? C class object with A and B. By the time this constructor is executed, you can see only the presence of AB because this constructor from A initialized C object with these two variables A and B with 100 and 200. When this constructor executes, B class constructor executes completely, then you can also see X and Y under the same C objects. Do what? Do that. Step over, step over. When I am saying step over, you can see adding that X here, adding that Y here, right? All that there. So that is the idea. Finally, control came back, right? So what happened to this? I think that somewhere that is broken. That should be fine. That constructor calling is completed and the control is written back, friends. Now what is that we should do step over? Now you can see by the time this execution of both constructors are completed, this object C is initialized with AB from A class and XY from B class, right? Next after that, it is calling get A. Get A just simply calls, okay, we just directly say step over so that it prints values from A class. Okay, you can see that in the console here. Okay, next one, again step over, it prints B, then it prints values from B class, and finally A. Add, add, adds that both values of A and B. 330 should be a perfect value. So this is the idea of what I think this 10 minutes discussion has a lot of information, friends. We came to know about few intriguing things here, especially about this is interesting thing, beautiful thing here. If you are calling a superclass constructor from a subclass, how do you do that? By applying this super method and calling that constructor. If it is Java or C sharp, we directly apply super. That is enough. You don't need to explicitly call constructor. But in Python, we should make explicit call. So that is the difference. If some of you are from Java, just FYI, got it right. So this is the idea, friends. I'm sharing this code base with you as well. If we have constructor in C class or C also, then do we need to explicitly mention super on A and B? We'll try that now, Rudra. Let's try that. Okay, let me share this code. That is a simple thing, but not an issue. Because now you know all that basic things, right? So you can play around as well, but it's okay. We are seeing a question, right? Let's do that now. So your question is, suppose you have a constructor here, copy this in C class. Okay, no problem. Let it have it. Okay. Then I think if we have constructor in C, then it might not call constructor of B or A. Let's check that. Okay. And you just put some M and N here. Okay. Just for different variables. And you put here some 1000 and 2000. The question for you is this, right? What is that? And again, still we can do add. To do add, what is that? You can just add some self dot m and self dot n. Okay, just leave it like this. First of all, yeah, definitely this chaining is needed. No doubt about that. We can invoke B class constructor from C. What this does, let's check. In this scenario, if you want, you can put a debugger. It's up to you. So, or else by quickly running, we can understand what the C class construct, what C class object will do. In this case, definitely C class objects gives priority to its constructor, not to B or A, right? So I think it will stop with M and N. I don't think it will try to go to B or A. Why? If B should go to A, before that C should go to B. You got point, right? So let's run this. Let's do that. You get an idea. So execute this, run. Yeah, you can see here. C object has no attribute A. Why? Because we start in right in the program somewhere when you call add method, you can see not add, even get A. When you call get A, if that get A method should display values of A and B. Those values should exist in C object or not. We are seeing that with the very practical this thing. Okay. So if this method should call A, B values from A class on C object, okay, those values must be there inside C class. How it is possible? By initializing. So finally conclusion is uh, I'm seeing name is yeah, I'm not sure if I should call Rudra or Ramoni. So but that is what. Now what is that? Simple. Now you know the approach, right? In that case, if you see that subclass constructor is not able to call its superclass constructor automatically, implicitly, then just add that explicit call. Use the super method and just pass it here, and your problem is solved now. And this will work, Ramoni. Okay. Sorry if my pronunciation is bad or something. Okay, but this is what we should do. Got it right? So if you want, you can do a quick tracing as well. Let's run this. This time it should work. See, same output. Very nice. But something extra. What is that? Some 3330. That's all, which is from the its own constructor as well. So let us do a quick debugging. Let's see the construct, this chaining of constructors, how this calls happen. This is too interesting again. Right. So again, this is a step into thing because a method call, do that step into, again step into, because this is a, when object is created, constructor is called constructor of C class, not B or A, because we have a constructor in C now. Then that will automatically call constructor of its own class first. So step into C, and this make a call to its superclass constructor B, and this make a call to its superclass constructor A. See, this is how it is. It's not just, so this is how the constructor chaining happens. Always the first that calls happen, and it is like calling happens from bottom to top, and execution happens from top to bottom. This is an interesting thing. I'll show you tomorrow. These all scenarios are really helpful. I'll show you the execution flow of these constructors in a stack frame. Stack frame. Okay. So that is important for you. Sometimes people ask you in interviews. Yesterday I have shown you heap, right? How it works, how where they are created, all that. Tomorrow I'll show you stack. So this is the idea. Finally, the execution happens step over, step over, step over, step over. You can see that. The initialization of C object happens, and finally, what is it? Get A will display AB from A class, right? Get B will display properties of XY from B class, but all are inside C class only. In C object, they are not in separate A object or B object. Everything is inside C. That's all. Okay. So next after that, add. Okay. Finally, when you add this, what happens again? Just that add that complete addition happens by using all those properties. Got it right. And final execution of main is over, and our driver program ends here. That is the execution. And finally, we have output here. If you want to while tracing, if you want to see the that variable creation and depth of variables, you can observe that here. Got it right, friends. So this is the idea. Did I share this? Let me share this also with you. Okay. So that is what this is all about. Did I hope I answered your question, Romani. Right. So tomorrow there is so much again to this. Maybe one more thing is what is it here? We are using default constructor calling. Suppose if constructor is parameterized, how should we call that using super method again? So these are all multiple scenarios. So we try to cover that as much as possible. But all this needs little bit of practice, and you have to try to run this again and again to sink this into your mind, friends. Okay, because I am doing this training programs, this development since almost 20 years. So all that is there with me. So initially it will take time, but you should practice, friends. That's all.